Warm welcome to Miss Amelia Amir, who will be moderating this Zoom session now. Welcome.
Thank you very much, Levrin and Rivaldo. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Honorable to FDTI Chairman Wilayah Barat, Profesor Dr. Engineering Insinyur Azrizal Aziz, STMT, IPU, and the Vice Chairman Insinyur Sapta Nugraha, STM, Master of Engineering, and then the of Faculty of Industrial Technology, Universitas Bung Hatta, Profesor Dr. Eng Reni Desmiarti, STMT, and then Vice Dean Ayubi Diawati, GR STM Eng, and then the committee chairman Erda Rahmi Laila Desfitri, STM Eng PhD, and all the member of the committee, and our honorable keynote speakers, invited speaker, and all the student as a participant, and also the lecturer, and all the participants today who join us today. Welcome to our keynote speech session on the first International Engineering Student Conference organized or collaborate. This event is a collaboration by FDTI and hosted by Faculty of Industrial Technology, Universitas Bung Hatta. I am Amelia Amir, and it's my honor to be a moderator today. And we will have 3 keynote speakers today. First, Professor Dr. Engineering Insinyur Adrizal Aziz, MTIPU. And then the second one, Associate Professor Yukio Hayakawa, and then Professor Dr. Engineering Insinyur Haji Joni Arliansyah, MT. Before we begin, may I briefly introduce our keynote speakers, and please, maybe one of the committee share the CV of our keynote speaker today, so everyone can see on the Zoom screen. First, let's see a briefly CV of Professor Dr. Engineering Insinyur Adrizal Aziz. Wait a moment, we wait for the screen. Okay, share screen. Okay. Maybe a little bit slow, please. We see that Professor Dr. Engineering Insinyur Adrizal Aziz completed his Master Engineering at Bandung Institute of Technology and earned his PhD at Saga University, Japan. And Professor Adrizal has many publications on Scopus and also Sinta. Latest publication maybe didn't show in the screen. Performance enhancement, maybe please stop a moment. Latest publication, performance enhancement of split air on Scopus conditioner during evaporative cooling application. And Professor Adrizal also reviewer various reputable national, and now as a dean of, Dean of the Faculty of Engineering at Riau University for the 2020 and 2025 period. Okay. Next, we can see also the many award of Professor Adrizal Aziz. Okay, you can see on the screen. And the next, we move to Associate Professor Yukio Hayakawa. As we can see on the screen, Associate Professor Yukio Hayakawa, now as Assistant Professor at Faculty of Engineering, Gifu University. And we can see the topic of the publication, I can see here, development of device for producing high purity hydrogen from ammonia using atmospheric pressure plasma. And several awards, Young Outstanding Lecture, Velo Award, Japan Society of Mechanical Engineer, and many others. And then we move to Professor Dr. Insinyur Haji Joni Arliansyah. Please. Okay. Professor Joni Arliansyah completed his Master of Engineering at Bandung Institute Technology and earns his PhD at Nagaoka University of Technology. And Professor Joni Arliansyah also has many publications on Scopus and also Sinta. And now, now is, okay. It's just, okay. Okay. So that is the briefly CV of our keynote speakers. Next, I will briefly explain the rule of this session. Okay. We will have total 105 minutes for this session. Each of keynote speaker will have 25 minutes for the talk, and we will have the Q&A after all keynote speakers deliver the speech. Yeah, maybe Q&A about 30 minutes at the end of the talk and then for all the conference participants, you can ask a question by typing your question on the chat button. Yeah, you can see it under the Zoom screen in your Zoom application, or you can also raise your hand if you want to ask the question directly to our keynote speaker. Okay, and then so that is the brief rule of our session. So it's time to start this speech session. We will invite Professor Azrizal as our first keynote speaker today. Professor Azrizal will deliver speech with the topic research on refrigeration and air conditioning for energy efficiency. Professor Azrizal, have you joined with us?
Okay.
Good afternoon. Selamat siang, Pak.
Okay, selamat siang. Good afternoon.
Thank you for joining us. And
Okay.
Now, Pak, 25 minutes for a talk, and then
Okay.
the question and answer we will have at the end. And now the time is yours, Prof.
Okay. Can you give me connection as a co-host to deliver my presentation? I will try share screen. Okay, thank you. Okay. You can see my presentation. Excuse me.
Yes, Prof. Yes, Prof. Clear.
Okay.
Very
Yes.
clear.
Okay, I will.
Yeah.
Okay, I will start to my presentation. Okay, thank you very much for time. You give time for me. I will present my research with title Research on Refrigeration and Air Conditioning for Energy Efficiency. This topic, my research, talk about refrigeration, air conditioning, and efficiency. And this slide, I will give presentation and explanation about energy efficiency for refrigeration and air conditioning system. I divide into around 4 topics: combined air conditioning and water heating system, or we can call air conditioning water heater system. And then hybrid air conditioning with hydrocarbon refrigerant as substitute halogenated refrigerant. Now we call and we use usually the new refrigerant as substitute halogenated refrigerant is R32 refrigerants. And next, energy saving on residential air conditioning using condenser with evaporative cooling and heat recovery system for water heater. And last, hotspot water heater on navigation system. Why we use combined air conditioning and water heating? Because the sizable percentage of electricity generated in watt consumed by refrigeration and air conditioning system. And in tropical countries, the use of split type air conditioning are generally used in residential and commercial building. So in such establishment, electric water heater are often used to generate hot water. So both air conditioner and electric water heater are generally the major energy consuming device in the building. And if we use refrigeration and air conditioning, which consume around 50% of home electricity and around 19% for water heating. If we combine the use of refrigeration and water heating in refrigeration system, we can decreasing the use of electricity in home. Okay, and this okay, next. Okay, we can see this vapor refrigeration component or refrigeration cooling system. We can make efficiency in the component of condenser. Okay, and this is the next slide. If we use refrigeration system for cold refrigeration space, we call refrigerator. And we use refrigeration system for warm house, we call heat pump. And if we combine the heat pump and refrigerator, we call combined refrigeration system. In this system, refrigeration system can make a cold refrigeration space and also warm house. This combined air conditioning and water heating system, and we can this refrigerator this heat pump and this combined refrigerator and heat pump. If we combine refrigerator and heat pump, we can accept coefficient of performance for cooling effect and also for heating effect. This heating effect, we can use the rejection of energy from condenser. Yes, this is a main component of refrigeration system. One is compressor, second is condenser, third is expansion valve, and the fourth is evaporator. The heat rejection from condenser we can use to heating water, or we can use for drying other system. And this presentation we use heat rejection from condenser from condenser to water heating system. This area for heat recovery. Yes, this area for heat recovery, and if we see in, we can see in schematic diagram and TS diagram, the heat recovery we can use in this line. Yeah, we put heat exchanger between compressor and condenser, because between compressor and condenser, or after outlet compressor, the heat of the temperature of refrigerant is very high, so we can use this for water heating. Okay, this is also the combined refrigeration and air conditioning system. We can use post heat recovery, and we can we put heat exchanger, or we call the superheater, for reclamation tank to heat water in the tank. Yes. After compressor, we put water heater, reclamation tank, and after refrigerant go to water heater tank, and then go to condenser. So the use of this system not disturbing the performance of refrigerant system in existing. Okay, this type of coil condenser we can use in water heating system, in water tank, to heating the water in the tank, using heating effect in condenser, or heating effect after compressor to condenser. Okay, this is a helical coil. This is a trombone coil. This experimental room used to testing this water heating system. Okay. Go to the conclusion. Okay. You can see in this graphic, the temperature of the heating in 2 hours reclamation tank with coil at various cooling load. We can see with the cooling load and with cooling load, the temperature of water we can make to heat to water heating around 2 hours. In the conclusion, we can see the application of air conditioning combined with water heater using coil not affected the cooling performance, but it can improve energy performance considerably for cooling and heating. The use of trombone coil condenser gives better performance than helical coil condenser. When the cooling load increases, the COP, or coefficient of performance for refrigeration, and coefficient performance for refrigeration and heat pump also increasing. So we can use this combined air conditioning and water heating system without affecting the cooling performance. Okay. Next, for air conditioning with hydrocarbon, you can see if we change the refrigerant with hydrocarbon refrigerant or low GWP and low ozone depleting potential, then we can also make consumption of electricity if we use hydrocarbon refrigerant. The investigation previous researchers shows the application of hydrocarbon refrigerant can reduce electric power consumption around 10 until 30%. And also, this hydrocarbon refrigerant is the environmentally refrigerant that has zero ozone depletion and also very low global warming potential. This advantage of refrigeration hydrocarbon as refrigerant. The result, if we use hydrocarbon refrigerant, the pressure of condenser is low, and also the pressure of condenser evaporator is low. If pressure in condenser or evaporator or in compressor low, it means the consumption of electricity for compressor is also low. So we can save energy consumption around 10 until 30%. This. Okay. Power consumption of compressor more efficient 35.12% compared to R22, where the condenser evaporator pressure also lower than use of refrigerant of R22. Okay, this next also energy saving on residual conditioning using condenser, and we put evaporative cooling in front of condenser, and we can use heat recovery system for water heater. Yes. This is same with the next with the previous research, but we put evaporative cooling to make temperature, air temperature to entering condenser lower than temperature without using evaporative cooling. If we use evaporative cooling, the temperature entering the evaporator, we can reduce around 2 until 5 degrees of Celsius. This location to put evaporative cooling to decrease pressure of condenser. If we can decrease pressure of condenser, it means we can decrease the electricity for compressor. Okay, this location for evaporative cooling. This figure from Haji Davalo and Ekdetari, his research 2010, he put evaporative cooling before air entering the condenser. This using water injection pipe. Yes. Okay, next. Okay. In this slide, we can see this location for put of evaporative cooling. We call evaporative media pad, and this water pump. This water pumping to the evaporative media pad, and we make the evaporative media pad is decrease the temperature before entering the condenser. Okay. Okay, this is a figure of the evaporative cooling. Okay. We can see in this electricity consumed in conditioning is most electricity consumed in conditioning for human comfort used for air conditioning. We can see for hotel around 60%, for hospital around 57%, also for shopping mall, also for government office around 55%, and in residential home or office building around 47%. And if we put evaporative cooling and we change the refrigerant, we can make decrease the consumption of electricity for air conditioning. Okay. This type of direct evaporative cooling we can use for decreased temperature before entering the condenser. This type schematic diagram of split air conditioning with direct evaporative cooling. Okay. And to make energy efficiency for refrigeration system, we can use condensate. There is water from condensation of water from indoor or from evaporator. We can use this condensate water as source of evaporative cooling, water source for direct evaporative cooling. Okay. Self-compressor power consumption due to the decrease in condensate temperature and pressure ratio will enhance overall of COP, coefficient of performance of coefficient of performance for refrigeration system. Yes. Okay, we can see this position of evaporative cooling unit or modular evaporative cooling. This is outdoor unit or condensing unit. We put in the back of condenser. This our evaporative cooling product or module evaporative cooling that we make in our laboratory. Okay, in this hotspot water heater, the same with hotspot water heater that use hot refrigerant from compressor to the condenser. This photograph of hotspot water heater in refrigeration system. And we can also use the rejection, what was heat rejection from condenser to make as for drying. We can use for cloth drying. Yes, this system of drying machine using refrigeration system. Okay. Okay, this is a figure of residual air conditioning combined with water heater system. This residual air conditioning combined water heater to enhance the performance of water heater, to enhance the performance of refrigeration system. Usually now refrigeration system using a new model of heat exchanger. Yes, he used condenser with aluminum micro channel coil, better than condenser with chopper pipe coil. Usually now refrigeration system using condenser with aluminum micro channel coil. Okay, this is the last energy saving on the refrigeration system and air conditioning, and we make some part in the refrigeration system. We can make saving energy for refrigeration and air conditioning. Why we must saving energy refrigeration for refrigeration system? Because the use of electricity energy for refrigeration and air conditioning around 45% for home or for office or for mall on the others for refrigeration system. Okay, this complete my presentation. Thank you very much for your attention. Okay.
Thank you very much, Prof. It's very good and interesting research since we use mostly air conditioning and also refrigerator in our daily life, especially in Padang is very hot, right? Recently. And we now, maybe for the question and answer, Prof should wait until all of our keynote speakers finish delivering the speech. And then let's move to the second, for our second keynote speaker, Associate Professor Yukio Hayakawa.
Amelia,
Yeah,
excuse
Prof?
me, Amelia. If the question and answer a question from audience, because after that I will leave this Zoom meeting because I have other activity.
So
If the question from audience or from okay.
Oh, so we
If any question, please. Yes.
Okay.
If any question.
Okay. Hayakawa Sensei, maybe ちょっと待ってください. Maybe wait a moment. Since maybe we will wait for the すみません、先生。maybe we will wait for the participant. If
not question, I think it's okay.
No,
I have question. Sorry.
No,
Okay, Mr. Iman.
Yeah. Okay. Hello, Prof.
Yes. Hello, Mr. Iman. Nice to meet you.
Yeah, nice to meet you. Yeah. Thank you for the moment. Yeah. I think the research is very interesting and can set with a lot of energy. My question:
Yes.
has the research been commercialized, and what are the obstacles, if any?
For commercialization.
Yeah. Jadi has the research been commercialized? Jadi and what are the obstacles, if any?
Okay.
Your research, yeah.
Yes. Okay, thank you for your question. For commercial application system, now usually use new refrigerant. We can call R22 refrigerant. This refrigerant is we call low flammable refrigerant. Yeah. This low flammable from hydrocarbon refrigerant. Yes. I think it's this the technology use new refrigerant, that this is refrigerant experimental refrigerant, and this with this refrigerant the consumption of electricity will decrease, but we know that the use of refrigeration system will consume more energy for electricity, and this different with other area. Yes, in Asia usually use air conditioning for cooling and also for heating, but in I see in Europe not use refrigeration system for cooling or for heating. Usually use other system for cooling and heating, but the use of refrigeration system is more used in Asia, especially Indonesia. We use many refrigeration system to cooling system in our house or our space or room. This is my question.
Okay, Jadi, so are there any company interest your research to develop? Are there any company interest?
No. I don't have any company to as company join for my research. I don't have company join my business. By next we will make the produce the refrigeration system for energy efficient, like effective cooling module, or like water heating, air conditioning water heating system, like tank for water heating system for air conditioning, we can produce this product, and maybe next time we will join with other industry to support our research.
Okay, good luck. I hope so.
Okay.
Okay, thank you.
Thank you, Mr. Iman.
Thank you, Prof. Yeah.
Yes, thank
Maybe
you
we
very
can
much.
wait one more question, Prof,
Okay,
from the
okay.
participant.
Yes.
I hope the student who joined with us can also asking about this topic.
There is other question from audience. I think no question, Miss Amelia.
Is it okay if I ask the question, Prof?
Okay, okay, okay. It's okay, okay.
Yeah, actually, I'm interested in this topic, and since it's kind of combination air conditioning and water heating, and also about the refrigerant material using hydrocarbon. Yes,
Yes.
yeah, Prof. And
Yeah.
I just curious about this hydrocarbon as the refrigerant.
Yes.
I know that it's a non-toxic,
Flammable.
non-toxic
Non-toxic, but
material.
flammable.
But yeah. So what is the weakness? I mean, is it
I think
very?
okay. I will answer. I think this is not a weakness. The use of refrigerant as the hydrocarbon as refrigerant. We know we use motorbike or motorcycle, and we put petrol tank in
Yeah.
below our in this motorbike. This I think is a very flammable than refrigeration system.
So this properties is okay, yeah, Prof. Yeah, I mean the flammable.
Yeah, it's okay.
Properties of this
Yes,
hydrocarbon.
if we use the hydrocarbon refrigerant, the technician that service or maintenance the refrigeration system must certificate as technician.
Okay.
The technician must careful and make attention before service refrigeration system with hydrocarbon refrigerant. And I will tell you the refrigerant now around 90% of refrigeration system, residential refrigeration system, split air conditioning used and usually maybe in Asia and other world, we use R32 refrigerant. R32 refrigerant is flammable refrigerant, but we call low flammable refrigerant. It's flammable but low flammable.
Okay.
It's mean also flammable, but usually the new refrigeration system in that sell in Indonesia and other countries use R32 refrigerant. You can see if you buy new refrigeration system or new air conditioning, the refrigerant is
brand maybe.
R32.
What
Yes.
brand? What brand?
Many brand now use R32. Many brand.
Okay.
Yes.
Okay.
Because
So
R32 is non-halogenated refrigerant. In this fermented refrigerant, we can use for long time refrigerant change.
And it's also environmental or climate friendly.
Yes, also low global warming and low ozone depleting potential.
Yeah. So because we know that the problem, ozone
Yes.
climate problem for the air conditioning and
problem,
also
yes.
refrigerator. Okay, Prof. Thank you
Okay.
very much.
Okay, thank you
Maybe-
very much.
Okay.
Okay.
Thank you,
So
Prof.
excuse me, I will leave from this Zoom meeting because I have any activity. Thank
Okay,
you
Prof.
for time for me, and thank you for Kaudian. We hope this conference will success.
Okay, thank you,
See you.
Prof. Yeah, see
Thank you.
you.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Adrizal Aziz. That's a very interesting topic. And then I think we will change a slight, the slightly change our rules. And maybe after the talk, 25-minute talk, we will continue to the question and answer. And now we invite our second keynote speaker, Associate Professor Yukio Hayakawa, that will deliver the speech with the topic Carbon Recycling Technology Using Atmospheric Pressure Plasma. Hayakawa Sensei, are you joining with us? While waiting Hayakawa Sensei to join with us, maybe we can take a break for a while. Okay, while waiting the Hayakawa Sensei join with us, I remind all the conference participants, you can ask question by typing your question on the chat button. You can see under your Zoom application. And then, or you can also raise your hand in Zoom application if you want to ask directly to our keynote speaker. Hayakawa Sensei, have you joined with us?
Hi.
Sensei, hi. Okay. Next, we will have Hayakawa Sensei from Gifu University will deliver the speech with the topic carbon recycling technology using atmospheric pressure plasma. Konnichiwa, Sensei.
Konnichiwa. Hello.
Now time, okay, hello, Sensei. Now time is yours, Sensei. 25 minutes for the talk. And then should we continue to the question and answer after the speech?
Okay.
Okay. Dozo, Sensei.
Okay. Can I share my presentation file? Okay.
Yes, you can share. Okay.
Do you see my presentation file in slideshow?
Yeah, not slideshow. Yeah, okay.
Okay. Hi, hello everyone. I am Yukio Hayakawa, and I'm assistant professor Gifu University in Japan. Thank you very much for this opportunity to give a keynote speech on IESG today. In this talk, I'd like to introduce the result of my research on plasma processing of CO2. This presentation title is Carbon Recycling Technology using Atmospheric Pressure Plasma. My presentation is divided into 3 parts. First, I will introduce the research in our laboratory. Next, I will present the result on plasma decomposition by CO2 decomposition by plasma. And finally, I will present the result on graphite formation from carbon monoxide by plasma jet reaction. So our laboratory is staffed by 2 researchers, Professor Kambara and me. The chemical engineering is our field, and we are working to solve technical issues related to the environmental pollution and energy resources. Recently, our main research topics are hydrogen production from ammonia and carbon dioxide conversion to variable resources. We use not only some chemical processes, but also atmospheric pressure plasma treatment with dielectric barrier discharge called DBD, and hot chemical reaction processes with vacuum ultraviolet rays. Today, we will talk about the CO2 conversion topics, both related to CO2 processing by atmospheric pressure plasma. So now let's move on to the main issue. I present on CO2 decomposition by atmospheric pressure plasma reactor. Let us begin with the social background of this study. There are many concerns regarding CO2 emissions. The CO2 emissions from the industrial sites, power plants, homes, and transportation are widely considered responsible for global warming. The high concentration of CO2 in the atmosphere is the main reason for global warming, a global temperature increase, and associated climate change. One of the solutions to this greenhouse gas problem is carbon capture and utilization techniques called CCU. The CO2 emissions are captured and then utilized to produce high-value chemicals and fuels. For this purpose, the non-thermal plasma is a promising method, especially the DBD plasma. In recent years, DVD reactors have been attracting widespread interest for CO2 conversion due to their simple design and which is beneficial for upscaling for real applications. In addition, these reactors are easy to turn on and off by controlling the electrical power supply. So now let's move on to the DVD plasma CO2 decomposition. So DVD is the electrical discharge between two electrodes separated by an insulating dielectric barrier. The plasma discharge in DVD reactors present a filamentary that consists of micro discharges. The plasma discharges in DVD reactor, when CO2 gas passes through this discharge, it faces a high concentration of plasma electrons, resulting in CO2 dissociation by electron impact reaction. This reaction produced carbon monoxide and oxygen gas, CO and O2 gas. Furthermore, these reactors typically operate at atmospheric pressure and near room temperature. The main reaction for CO2 decomposition is electron impact reaction. And with an activation energy of about 7 electron volts. Whereas DVD can provide electron energy in the range from 1 to 10 electron volt. However, DVD has disadvantage. So the main disadvantage of DVD reactor is that conversion rate and energy efficiency are still low. For this reason, this research investigated the influence of micro gap discharge length combined with the impulse power supply on the conversion and the efficiency of the CO2 decomposition process. This slide shows experimental setups. The plasma reactor is a tubular DVD reactor that consists of the electric tube and two concentric cylindrical electrodes. The inner electrode is a stainless steel rod, which is grounded. The outer electrode is a stainless steel coil placed around the electric tube and connected to an impulse high voltage power supply. The dielectric material is quartz. Firstly, the CO2 gas was fed through the reactor, and the gas flow rate was measured by a mass flow meter. Then the DVD reactor was powered by an impulse voltage power supply, a high voltage and current probe used to measure the applied voltage and current. In addition, the charge generated in the discharge was measured by the external capacitor. And then all the electrical signals were sampled using a 4-channel digital oscilloscope, and the feed gas and the produced gas were analyzed by a gas chromatography instrument to determine the molar fraction of CO2, CO, and the O2 gas of the outlet gas. This table gives the experimental condition for the CO2 decomposition by impulse DVD plasma. The discharge gap is a gap between a quartz tube and ground electrode rod. The gas flow rate is varied from 20 to 100 milliliter per minute, and applied voltage is changed from 12 to 18 kilovolts. And then the conversion rate and energy efficiency are defined from the experimental data following these equations. Especially specific energy input is an important metric for evaluating plasma processing and indicates the amount of energy required to dissociate 1 liter of carbon dioxide. So specific energy input called SEI. Here we can see the applied voltage and the current waveform of the impulse DVD reactor. Both the rise time and the fall time of impulse voltage are about 2 microseconds with a pulse repetition frequency of 10 kilohertz. And the impulse power supply is manufactured by Hayden Laboratories in Japan. This slide shows the discharge power. The discharge power was controlled by changing the applied voltage and calculated using the Lissajous figure method. It is calculated in proportion to the area of the diamond in the graph. For example, at applied voltage is 12 keV, discharge power is calculated to about 34 watts. So first, let's look at the effect of discharge power to the CO2 decomposition. This graph shows the influence of discharge power on CO2 conversion and energy efficiency. Increasing discharge power increased CO2 conversion, but decreased the energy efficiency. A trade-off relationship between CO2 conversion and energy efficiency clearly can be seen where a high CO2 conversion is achieved at low energy efficiency. For example, CO2 conversion increases from 10.17% to 20.25% to 5%, as the discharge power changed from 34 to 101 watts, whereas the energy efficiency decreased from 6.47 to 4.17%. This is technical issue of CO2 dissociation by atmospheric pressure plasma. This figure shows the current waveform for different discharge power. The non-streamer formation was decided at the applied voltage of 12 keV. So non-streamer formation. Sorry. The increasing the applied voltage to 14 keV produced the streamer formation. The changing the discharge regime to a combination of uniform and filamentary mode. The formation of the streamers suggests electron impact reaction channels for CO2 dissociation. In addition, a higher current peak means a higher density of electrons and ions, resulting in more reactive plasma. This condition might contribute to the higher CO2 conversion at a higher discharge power. Furthermore, the discharge power of the impulse DVD does not affect the streamer intensity. This is a contrast with the conventional alternating current DVD. This is low energy, low discharge power and high discharge power. However, increasing discharge power gives rise to the peak value of streamer and the overall peak-to-peak value of discharge current. Let's look at the effect of the gas flow rate as shown in this graph. The residence time of CO2 gases in the plasma reactor decreased from 9.7 seconds to 1.9 seconds as the flow rate increased 20 to 100 milliliter per minute. And the CO2 conversion decreased from 51.42% to 15%. The reduced residence time of reactants in the plasma decreases the possibility of collision with electrons and chemical reactive species, consequently lowering the CO2 conversion. On the other hand, energy efficiency of reaction was increased from the 4.1% to 7.2% by increasing the feed flow rate. However, further increase of the gas flow rate to 100 milliliters per minute reduced the energy efficiency. This lower energy efficiency is due to considerably lower CO2 conversion value at a gas flow rate of 100 milliliters per minute. In contrast to discharge power, decreasing gas flow rate significantly affects the formation of streamers, as shown in figure 9. The more current peaks with higher peak values were observed at lower gas flow rate. The higher streamer intensity produced more electron impact reaction channels for CO2 dissociation. In addition, the high value of electron density indicates the generation of more active species in plasma for the CO2 decomposition process. Moreover, a longer residence time, which arises from a lower gas flow rate, that means that the CO2 molecules can stay longer within the streamers, thus resulting in higher CO2 conversion. So now, let's look at the last part of the experimental results, which is the effect of specific energy input SEI. The variation of SEI can be achieved by changing the discharge power and gas flow rate. How we change the SEI has a different influence on the CO2 conversion and energy efficiency. From figure 10, we can see that changing the SEI by varying the gas flow rate results in a beta increase from black symbol to blue symbol. Therefore, the gas flow rate seems to have a more pronounced effects on the conversion than the plasma power. On the other hand, the plasma power plays a more important roles in the determining energy efficiency. So more effective. So this slide shows summary of the CO2 decomposition by DVD. The very high CO2 decomposition rate, about 50%, were obtained by combining the microgap DVD with an impulse power supply. And the gas flow rate and the streamer intensity were found to play a more dominant role in CO2 conversion than discharge power or peak-to-peak current. For future research, the impulse power parameters such as rise time and repetition frequency need to be optimized to increase the energy efficiency. From this research, we have successfully converted carbon dioxide into carbon monoxide and carbon particles. However, the deposition of carbon particles shows the possibility of carbon dioxide immobilization. However, there is a technical problem that carbon deposition occurs in the plasma reactor, inside plasma reactor, making it difficult to separate and recover carbon particles. To solve this technical issue, the adaptation of plasma jet technology was investigated as a method to separate and recover carbon particles. The plasma jet is a method that can irradiate the excited gas by DVD to the outside as shown in figure 12. The figure 13 shows a photograph of a plasma jet in which argon plasma is externally irradiated from the device. The various types of plasma can be radiated to the outside by a plasma jet reactor. In this study, the external deposition of carbon was attempted by the irradiated carbon monoxide plasma to the outside target for carbon particle deposition. This slide shows an overview of the plasma jet device. It consists of a high voltage rod and a quartz tube and a copper foil for the ground electrode. The sample gas is excited in the gap between the quartz tube and the high voltage electrode rod. And the excited gas is irradiated through the gas outlet. This figure shows the experimental setup for irradiating the target with CO plasma. The plasma jet device was installed in a desiccator. The plasma was irradiated to the target as shown in figure 16. The carbon particles were deposited on the target. In this photograph, the target is nickel plate. The carbon particles, the distance between the plasma jet and the target could be changed. The inside of the desiccator can be filled with nitrogen gas or air. This slide shows experimental conditions for CO plasma irradiation experiments. We use mixing gas, and CO concentration is 50% and diluted by argon gas. The gas flow rate is set to 1.5 liters per minute. The next power supply condition, applied voltage of plasma irradiation is set to 70 kV and repetition rate is set to 10 kHz. And the irradiation distance between plasma jet device and the target is set to 10 millimeter, and the irradiation time is varied from 30 to 90 minutes. Atmospheric gas is used, air or nitrogen gas in the desiccator. We use six kinds of target: the nickel, copper, iron, aluminum, and paper and wood material targets. This slide describes the result of irradiating a nickel plate with carbon monoxide plasma. The photo on the left shows the nickel plate irradiated with CO plasma. So black particles were deposited on the plate. The particles were observed under magnification by SEM. The magnification was 30 times. The particles were deposited in a reticulate pattern on the plate. This suggests that the carbon particles were deposited after the reaction between the nickel plate and the CO plasma. And now let's observe the carbon particles more magnified. So this photo is more magnification, about 5,000 times. When the target was irradiated with CO plasma, many carbon particles were deposited. This result indicates the carbon particles produced via carbon monoxide, and the carbon particles were deposited to coat the target, and carbon particles of various size were deposited: big size, small size, various size. Presumably, the carbon particles were deposited on the plate and the glue size. Based on these results, various conditions were changed. For example, atmospheric gas, target materials, and irradiation time. This slide shows the effect of ambient gas. The many carbon particles were deposited in the nitrogen gas environment. On the other hand, no carbon was deposited in the air environment. The sample gas contained argon gas. The argon gas became argon plasma by DBD, and it excited oxygen in the ambient gas. The excited oxygen is reacted to the carbon particle to carbon oxide or carbon dioxide. Therefore, it is considered the carbon particles were not deposited in the air condition. This slide shows the effect of plasma jet irradiation time. When the irradiation time was short, right side is irradiation time 30 minutes, and the left side irradiation time is 90 minutes. When the irradiation time was short, the size of deposited carbon particles was small. The size of carbon particles increased as the irradiation time increased. It was found that the carbon particles grew size with the irradiation time. And various targets were irradiated with carbon monoxide plasma. As a result, no carbon was deposited on paper and wood. It is considered that the target must be conductive. For the metal targets, the amount of deposition was different. The most carbon particles were deposited on copper plate. From this result, it can be inferred that the smaller the ionization tendency of the metal, the more carbon was deposited. However, the mechanism of carbon particle deposit is not yet known. Finally, the carbon particles obtained in this experiment were structurally analyzed by Raman spectroscopy. The obtained particles had a strong peak in the G band about 1500 Kaiser. This result indicated that the carbon particles obtained from carbon monoxide have a graphite structure, and the carbon particles have the potential to be used as carbon electrodes. So this is summary. Summary will be omitted as it is beyond the time of the presentation. So thank you for your kind attention. I will not be able to participate in discussion part, so sorry. Thank you.
Thank you very much, Sensei, for the delivering the speech about this carbon recycling technology. And then it's time to taking a question from the audience. Okay, let's see. Oh, okay. We have a question from the chat. Please. From Fajar R. Tampu Bolon. Okay, I will read the question, Sensei.
Hi.
Professor, what if we add water to convert CO2 into glucose rather than reducing CO2, which can produce CO?
From glucose
Fajar.
production.
Right. Okay. So there's glucose production from the glucose production reaction.
The water and the CO2 reaction. So the probably so maybe the CO2 and the water reacted to glucose and the oxygen. So by the using plasma, I think that this reaction is difficult to glucose by plasma. But this reason is water treatment is difficult by plasma treatment. the water is dissociation to the hydrogen and oxygen by the plasma. However, hydrogen and oxygen is react to recombine to water, and so it may be difficult.
Okay.
Okay.
So maybe difficult. Yeah,
By
sensei,
plasma
from-
process.
by plasma process.
Thank you, Professor.
Next, we wait another question from the audience. You can also ask directly, I mean, not only typing your question, but asking directly to the Hayakawa Sensei. Okay, let's see another message. From Wahyudi. Wahyudi, maybe you can ask directly? No? Okay. Okay, I will read the question from Wahyudi. I'm very interesting for this research. I have a
Thank you.
question, Prof. In case gas emission, the gas usually has contaminated compound such as NOx, SOx, and particulate. Do the compound become disturbance for this technology?
Okay. So this is a good question. So exhaust gas is contained in general contained NOx SOx. The NOx SOx, so in the past I tried to NOx decomposition by the plasma. This is difficult to NOx decomposition. However, now so we target to in this experiment, we target to large scale plants from, for example, ammonia production plant. So the in big size plant have the CO2 separated technology called CCS, carbon capture storage technology. So only CO2 is separated from the exhaust gas. Now we use high concentration CO2 that not contain NOx SOx. If NOx SOx are contaminated to the CO2, so now maybe no effect to the CO2 decomposition because NOx and SOx is difficult to dissociation by plasma method.
So NOx and SOx will not dissociate with CO2 when we use plasma method, Sensei.
So
okay. So
yes.
Okay, thank you, sir.
Okay.
Thank you. Good comment. Thank you.
Maybe another question. We still Okay. No question. Okay. Okay. If there is no question anymore from the audience, maybe we can move to the next keynote speaker. Thank you, Sensei.
Thank you so much. If you after that, if you have a question and the opinion, please send to message Dr. Elda-san. So or directly to me.
Okay. For all audience, if you have a question, you can send us. I mean, to the email, maybe to Erda.
Or direct to me. So
you can send a question by mail. Okay. Thank you very much, Sensei, for the interesting topic today.
Sama-sama.
Bye, Sensei.
Bye.
Okay. Next, we will invite our third keynote speaker, Professor Dr. Eng Insinyur Joni Arliansyah, that will deliver the topic about choosing the type of mass public transportation for cities in developing countries. Professor Joni Arliansyah, have you joined with us? Okay.
I already joined.
Okay, Prof, time is yours. 25 minutes for
Okay.
the talk.
Okay, I will share my presentation.
Okay, please.
Okay, thank you, moderator. Thank you for the opportunity to present my matter related about choosing the type of mass public transportation for city in the flow country, case study regarding LRT in Palembang. My material is very general. Hopefully everyone can follow my presentation easily. Okay, my name is Joni Arliansyah. I am the head of transportation laboratory in the Civil Engineering Department, Faculty of Engineering, University of Sriwijaya. Okay, to choose the mass transportation competition in city, we begin with a question about which type of mass public transportation suit with the character of the city or our city. And so that to fulfill the purpose, we have to think that we have to make a plan to guarantee that we don't make a wrong choice in public transportation. Because the choice of the public transportation option is the choice about the future of the city. There will be the question how to solve or to answer the question, will there any big traffic jam anymore? And will be there a high level of air pollution or noise pollution? And is transportation affordable? Will the service be available to everyone? The type of publication system that will be or that you chose will be have a broad impact on the answer of this question. I start with the types of mass transportation. Okay, in general, there is three type of mass public transportation type. First is bus rapid transit. Everybody knows, maybe in Jakarta already the Fruitvale bus rapid transit. And another type is like rapid transit, including monorail, LRT. This is the elevated one. This is the run underground, on the ground. This is LRT. It's called light rail transit. Another type is heavy rail transit. In this case, we can find in Jakarta also the subway. This is the subway in America that called metro. And also there's a heavy rail transit elevated. This is BTS heavy rail transit in Bangkok. So which one we will use or we will choose for our city? For example, in Riau, which one? That's the question. Sometimes somebody will, I want to have subway in my city. I want to have a LRT. But you have to know which one is suitable for our city. That's our discussion today. We have to answer that question. Another question is, what factor are the main consideration in choosing the type of mass public transportation for the city in the following country? I mean, many consideration have to look at, but today I think I will explain about the three consideration, the three main consideration that have the basic to choose the type of mass public transportation. First is travel demand needs and construction cost and construction time. These three main consideration will be answered. What type of the mass public transit is suitable for your city? After that, I will discuss about LRT in Palembang. What is the problem about demand? What is the problem about the construction cost and etc. Okay, we start with the travel demand needs. Demand projection is very important for get the demand that will be load to the system. Demand projection is needed to determine which kind of transportation type, how much demand to serve. This demand can be find using many models, transportation model. For example, transit demand model, or you can use VCM. Basically, the model is four-step transportation basic. There's three generation, trip distribution, model split, and trip assignment here. This is the projected demand model in Palembang. This result based on simulation in our laboratory. This show us how much trip that will flow in a link, for example, in the road. Also, the link, the flow that flow in the rail line, something like this. This is important. So after we get the flow, we can know which type of urban transport can be served the demand. This is the example that produced from simulation. Please really let us discuss about this figure. This is the correlation of demand with mass transportation type. Here, this figure show that the unit used for the demand is passenger per hour per direction. Passenger per hour per direction. For example, if you only have less than 3,000 passenger per hour per direction, you don't need mass rapid transit. And after that, you can choose LRT between 6,000 and 12,000, and metro or subway between 25,000 until 45,000. You don't need to build a metro in your city if you only have a small demand. In this case, we can see that one of mass transportation type, which is bus rapid transit, it can serve the demand from small demand 3,000 until 45,000. This is the choice of the demand based on the traffic prediction. This means that please first predict your demand, or please knowing first how much traffic that will be served in your city in the line that you have planned. Based on the demand, we can estimate the type of transportation that is suitable for our city. This is the sample line or public transportation in many cities. This is the type, and this is ridership, passenger per hour per direction. For example, metro used in Hong Kong subway, Sao Paulo, Mexico City, and until Buenos Aires metro. We can see that the ridership is very high. And BRT also in Bogota until Curitiba in Mexico, there's a variation of ridership. Elevated rail, MRT, Bangkok SkyTrain also have a ridership. In Kuala Lumpur monorail, there is a 3,000 passenger per hour direction, and LRT in Tunis. This table can give us better picture of relationship between demand and the type of mass transportation that we can choose. So that if you have a very big or big ridership, you can choose the metro. You can follow this one. I think it's already using that figure to get the type of public transportation. And the second one is construction cost. The city financial capacity is important in choosing the type of mass transportation. It means that if the city don't have a lot of money, don't choose the type that expensive. For example, this is the passenger. BRT can serve from low passenger per hour until 45,000, and this is capital cost. How many million per kilometer? 1 million in today I calculate in rate of dollar. $1 million is about 15,398 million per kilometer. So it means that from this figure, we can know that if you don't have a lot of money, for example, if you have 3,000 passenger per hour that must be served, you can use the cheaper one, BRT. If you have enough money, you can choose the elevated rail, mass rapid transit, also underground metro, something like that. So it's very important. So if the city don't have a lot of money and a lot of money for maintenance and other thing that will be influence the cost of construction, you can use the cheapest one. The BRT is the cheapest one, I think. In Palembang, LRT is not cheap. It's about 10 million per kilometer until 40 million per kilometer. It's very expensive for development for the city in the developed country like Palembang. This is the example. How much kilometer you can get from the same money, the same cost, I mean. For example, if we want to build 40 kilometers of BRT, we can get 426 kilometers of BRT that can serve many networks in the city. If you build that the same of money to make elevated rail, you only get 15 kilometers. And if you use the money to build the subway, you only can get 7 kilo. It means that BRT, the cheapest one, and it can serve a lot of network in your city. Many network, if many link, it can be served by the BRT. And then construction time, the third one. Construction time, BRT is very fast to construct, about 1 or 2 years, 1 2 years, and LRT about 2 to 5 years. But in Palembang, because At the time, 2017, 2018, there is a Asian Games that will be open in the late of 2018. The LRT just built only about 1 year. Metro, because it's very high technology needed. For example, we have to build underground and we have to elevate the metro, the elevated rail. It is very long time, about 3 until 10 years. The length of construction period have been taking account in consideration. Is it can overcome the problem of traffic in the near future? And also during the construction, sometimes it's a very not convenient because the comfort of the resident during construction will be minimized because of the construction work. Okay, that's the basic of how to use the LRT. I will talk about the LRT in Palembang. LRT in Palembang, the length is about 23.4 kilometers. There is a 30 station. If you already visit Palembang, I think you will meet the LRT at the station Bandara, and then finally we will finish at the station Jakabaring. Jakabaring, and this is the JKA station, the final one. And then construction cost is very expensive. The construction cost is about 10.9 trillion rupiah. It's very expensive. Many discussion about the construction cost at that period, and then why this project still run. This project still run because the reason to build that LRT is the LRT was built to support the Asian Games with inaccurate demand prediction. This is the link of LRT, and this is the Kecamatan sub-district in the city, a lot of sub-districts. So, and I will show you this the demand using the origin destination matrix, because the prediction of this projection demand is not so accurate, and then doesn't serve for travel purpose because the origin destination is not only on this line. This is everywhere. Everybody want to go. So that doesn't serve much for travel purpose. So at that time and until now, we have a problem with the travel demand of the LRT in Palembang. Okay, this is the 2018 is only open for Asian Game. 2019 is open to public, and the time is only about 7,000 passenger per day, not passenger per direction per hour, passenger per day. If you compare with like Kuala Lumpur, for example, is only 3,000, but 3,000 passenger per hour per direction. This in Palembang is only 7,000 passenger per day. So after this is during the pandemic, the demand is decreased until 2,000 to 2,900 until 4,000, become better in 2020. This is the problem. So many afford to get the LRT demand. Government make a feeder transportation system. This is the link, and then we have a center of activity in near the line. So the feeder mean that the creation connection link between center of activity to the station. This is, for example, the link of feeder that have been done, and also in our laboratory we have many study to make a good link for feeder. And government opened the feeder for LRT in July, 7th of July 2022. This is the picture of the feeder system. It's very convenient and very cheap. In 2023 until July, we only have 12,000, or the average demand is only 12,000 passengers per day. So until now, still need other strategy to increase the passengers. This is the many research about this one in the city, how to make demand of LRT become increased. First, build park and ride facility for bicycle and motorcycle for all LRT station. And second, sideway facility for pedestrian connecting to resident area to LRT. So it means that trottoir must be have a renovation for pedestrian that connect or make a new pedestrian link from resident area to LRT station, and park and ride facility for the car that for at the station that have a big space, and crossing bridge, and also Pelican crossing, and also the city try to implement the traffic oriented development TODL at LRT station. This is the figure so that if you want to make a demand from near the station, this is a station. Everybody can walk from his house to the station. However, we have to make a good pedestrian and crossing for everybody to come to the LRT station. And this is the yellow one. This is the area that someone can use the bicycle, go to the station. However, park and ride for the bicycle is very important, because the security problem, if there is no guarantee that the bicycle will not lose during they use the LRT, they don't want to use the bicycle. In this is one. This is the picture of a park and ride for car, and there's a park on ride for the motorcycle here. It's need to increase the demand, and this is the park and ride for bicycle, sepeda, and also to make a good condition of trottoir, and also the crossing, and also pedestrian, and then this is Pelican Cross. And if someone want to just to pick up or to go there with someone drive for him or for her, this is kiss and ride, and the car come here, and then someone will go to the station, and then the car can go to another place. This is the thing that still try to be built in city of Palembang. This is the concept of the TOD. TOD is make a station as a center of activity. There is a TOD place that have been designed in Palembang. Asrama Haji, there will be one of the station. There will be hotel, and then the office, and then mall, and park and ride is here. Already have a plan, but during the pandemic and until now, there is maybe no investor want to build the TOD. This is still some TOD system in Chinde is now already built about 20 or 30%, and now it's stopped because a problem of investment. So there's the story about the LRT in Palembang, and also there is an idea that in station we can in central area we can facilitate the restaurant and also the cafe and station, so everybody can enjoy the food and coffee, make a coffee and restaurant. This also still run, but not so successful, I think. There's a little conclusion, I think, from our discussion this afternoon. Prediction of demand, cost, and also construction time are things that need to plan to get mass public transportation that suitable for a city. The experience in Palembang is also lesson learned for us to build another type of mass transportation in other city in Indonesia. Thank you very much.
Thank you very much, Prof. Johnny, for this very interesting topic. Actually, I'm not from civil engineering. Now it's time to have a question from the audience. Please, you can ask the question directly to Prof. Johnny, or you can type on the chat room the question, or you can raise your hand. Nobody? Okay, we will wait. Prof, is it okay if I ask the question?
Yes, please.
Maybe while waiting for the audience question. Actually, I'm not from civil engineering. I'm from chemistry, and I know I'm wondering if maybe in the future. I just want to know your opinion, Prof. In Padang, maybe for having LRT, maybe in the future. Is it possible? Or West Sumatra, maybe?
What I just explained that you have to check the demand, and also you have to check the ability of financial of the city. In Palembang, we can get the LRT because we have a moment that must be successful by center of government. So it means that all the money is come from central government. It is very expensive to make LRT in Palembang, and also expenditure of daily cost is also very expensive. From the passenger, it is not enough to operation expenditure in LRT Palembang. So every years, government of central government or have to subsidize just for operational expenditure. It's very expensive. So if you can, it's better for you. I think you in your city use a BRT that already success in many cities. Very expensive and can reach many place or many center of activity in Padang, I think. Yes, you have to be careful if you want to choose LRT. That's my answer to
Okay,
Amelia.
Prof. Okay, Prof. I think we have another question from Nofrizal El Sandi. What book or references should I read before planning public transportation, such as MRT, LRT, and BRT, Prof? Maybe you could respond directly.
Yeah, a lot of books that you can read. I have a lot of books about the book to make a plan on mass transportation in the city. Please connect Bu Amelia or who I will inform you. At least I can share the file,
Alright.
how to the book, how to make a plan of mass public transportation.
Okay, Prof. Maybe is it okay for the student to email you? I mean, for the next other
Yes.
question for the
I
maybe
will. Yeah, I will send my email to the chatting room. Yeah, we can continue to another question if available.
yeah. Thank you, Prof.
Yeah.
Okay. Is there any other question? Maybe for the student, you can check the email from the okay. Professor already sent email address on the chat. Maybe you can, if you have a question later.
Yes,
you
and
can,
if you need a book, also I will share. Yeah.
Yeah, you can ask the professor directly from mail maybe. Is there any other question? I hope the student give a question in this occasion. Please, we still wait maybe 1 or 2 more questions. Okay. Maybe there is no other question, Prof. Are we going?
Okay.
Should we close this session? Okay, thank you very much, Prof.
Thank you very much.
Thank you very much for joining us and for sharing for us this topic. And now we come to end of this session, and thank you very much for all our keynote speakers today. I think I would not to add another conclusion, and I will close this session and return to Lefrin and Rivaldo. Hello, Lefrin. I will return this the next session to the MC. Lefrin. Lefrin and Rivaldo. Lefrin and Rivaldo, please continue the session.
Halo.
Halo?
Udah.
Udah.
Halo.
Halo? Halo? Aku duluan. Bilang sama terima kasih sama Bu Amel Tiap itu kamu. Okay. Thank you, Miss Amelia Amir, SSC MSc PhD, to become our moderator today.
As we conclude this conference, we will share closing remarks, reflecting on the knowledge gained and the connecting made during this event. Once again, welcome to the International Engineering Student Conference 2023. See you tomorrow!
See you.
Okay, thank you. Dah, siap. Silakan dikasih apa ya, video apa yang bagusnya ya? Video FTI lah, video FTI yang tadi.
Halo semuanya, selamat datang di Fakultas Teknologi Industri Universitas Bung Hatta. Yuk kenalan dengan prodi-prodi yang ada di sini. Fakultas Teknologi Industri Universitas Bung Hatta terdiri dari 6 program studi unggulan, S1 Teknik Elektro, S1 Teknik Mesin, S1 Teknik Industri, S1 Teknik Kimia, Sarjana Terapan Teknologi Rekayasa Komputer Jaringan, dan Sarjana Terapan Teknologi Rekayasa Energi Terbarukan. Fakultas Teknologi Industri Universitas Bung Hatta merupakan salah satu instansi pendidikan terbaik di Pulau Sumatera. Hal ini dibuktikan dengan banyaknya prestasi yang telah kami raih, baik skala nasional maupun internasional. Hal ini diaktualisasikan dengan telah dapatnya akreditasi internasional IABI, dan semua program studi di Fakultas Teknologi Industri telah terakreditasi oleh BAN PT. Keunggulan lain dari Fakultas Teknologi Industri adalah banyaknya hibah yang kami dapatkan dari program MBKM, penelitian, dan pengabdian kepada masyarakat. Meskipun begitu, kami dari Fakultas Teknologi Industri akan terus berbenah diri, menantang diri untuk menghasilkan hal yang inovatif, kreatif untuk bangsa Indonesia. Fakultas Teknologi Industri unggul dan terkemuka.
Ngomong-ngomong, fasilitas apa aja ya yang ada di sini?
Fasilitas yang ada di Fakultas Teknologi Industri Universitas Bung Hatta seperti laboratorium, ruang belajar dengan fasilitas yang lengkap, ruang belajar outdoor, lapangan olahraga, dan masih banyak lagi. Fakultas Teknologi Industri Universitas Bung Hatta juga banyak bekerja sama dengan perguruan tinggi maupun industri, nasional maupun internasional.
FTI, one for all for one.
Wah, keren kan prodi di FTI? Keren dong. Mari bergabung di Fakultas Teknologi Industri Universitas Bung Hatta.